This is the method of factorising quadratics. We know it's a quadratic because the highest term is in x squared. Now, it won't just factor, we can't just take an x out, we can't just take a number out. So our result will be a binomial, or 2 really. It will always look like this. Now, what we do, we look at this number here, find numbers that multiply to make that, and they add together to make that. So I think to start with, it's worth putting down all the factors of 6. So we could have 1 times 6, we could have 2 times 3. It could also work negatively as well, so we could have minus 1 times minus 6 and minus 2 times minus 3. And that's all the factors that make up 6. And we look at these groups and we find numbers that when we add them together they make that coefficient there, 5. So 1 and 6, no, that's 7, 2 and 3. Here we are. 2 plus 3 makes 5. That would make minus 7. That would make minus 5. So there's our answers, and we put them in. It's plus 2 and plus 3. And just to prove it is actually factorising it, we could expand this and we should get back to that. So here we go, x times x, x squared, x times 3 plus 3x, 2 times x plus 2x, and 2 times 3 plus 6. Collect the like terms, those there, x squared plus 5x plus 6. And that is obviously the same. And that is how to factorise quadratics. I'll do a couple more examples. Okay, this one again. So numbers that multiply to make minus 16 and they add together to make plus 6. So let's have a look. We'll start with that. We could go minus 1 times plus 16. Well, that doesn't work. That's not going to add together to make plus 6. We could go minus 2 times plus 8. What about that? Oh yes, plus 8 minus 2, that works. So as far as we need to go. So x minus 2, x plus 8. And that's that one done. Now this is an interesting one. It's got to be numbers that multiply together to make positive 20. They add together to make minus 9. Now, they must be both negative. I'll show you why. So let's look at negative numbers only. Minus 1 times minus 20. Well, if we add those together, that's going to make minus 21. Of course, they multiply together to make positive 20. That's not the one. So we could try minus 2 times minus 10. Well, that makes minus 12 when we add them together. Minus 4 times minus 5. Now that looks better. Minus 4 minus 5 makes minus 9, and they multiply together to make positive 20. So there we are. X minus 4, x minus 5. And that's how to factorise quadratic expressions. I'm going to look in a moment about what happens when it becomes an equation and what actually these x's mean in that case. So let's look at an example of that. Now I'm going back to the first example that I did. This is this expression, x squared plus 5x plus 6. If we add an equal sign, call it 0, then that becomes an equation. So we can then solve this for values of x that satisfy this equation. We saw that this factorised to x plus 2, x plus 3. But now it equals 0. Now for any number to equal 0, when its factors involved like this, either that bracket must be 0 or that bracket must be 0, because 0 times anything will be 0, or 0 times anything will be 0. For this bracket to be 0, x must be minus 3. Minus 3 plus 3 is 0, or x is minus 2. So we can say x equals minus 2 or x equals minus 3. The value of x is always the opposite of whatever is there. So if that's plus, it becomes a minus. If that's plus, it becomes a minus. And that's the solution to that equation. One final point on factorising is this method that I've shown, where you find the numbers that multiply together to make that and add together to make that. That really only works when there's a coefficient of 1 on this x squared. You can factorise things with 2 or 3 x squareds there, but it can get a bit difficult, and I think it's best to use at times the quadratic formula, which I'll show you in another video.